For centuries, we've been craning our necks toward the sky. We build massive lenses to peer into the dark, scanning the stars in the hopes of finding something alive out there. This obsession with the cosmos means we've spent decades mapping the dead, silent surfaces of our closest neighbors. We know the exact layout of every single crater on the moon. We even know the terrain of planets millions of miles away, sending rovers to photograph desolate rocks orbiting invisible suns. This chart compares our topographical knowledge of Mars to the ocean floor right here on Earth. While the red planet is almost entirely mapped, we've barely scratched the surface of our own deep sea, a biome that covers more than 70% of our globe. It turns out we might be looking the wrong way. The strangest alien world we will ever encounter isn't floating in a vacuum light years away. It has been waiting beneath our feet this entire time. To cross the boundary from our sunlit reality into theirs, you have to seal yourself inside heavy steel. The descent starts in familiar blue water. Within minutes, the sunlight fails. The blue turns dark, then black, as gravity pulls the submersible through a heavy, infinite void, where the concept of a horizon disappears. This graphic illustrates what happens to water pressure as you drop deeper. By the time you hit 1,000 meters, the force pressing against the hull is 100 times greater than at sea level. Outside the sub, an unprotected human body would be crushed instantly. Yet, look out the window. Something is moving. A pale shape drifts past, perfectly calm. Life thrives here. When you strip away sunlight, warmth, and low pressure, evolution is forced to invent entirely new blueprints. The isolation shapes bodies and organs that would look perfectly normal on another planet. As you continue down, tiny flashes start appearing in the water. 1, then 5, then hundreds. They blink like a miniature galaxy. Jellyfish pulse with blue electricity, and shrimp release glowing clouds. It functions as a complex vocabulary. These flashes of bioluminescence form a communication network, used to signal danger, claim territory, or find a mate. But when we turn on our own floodlights to see them, the dynamic shifts. In total darkness, bright artificial light turns a research sub into a giant beacon, announcing your location to everything nearby. And plenty of things are watching. Take the anglerfish. It adapts to this environment by hanging a glowing lure right above its massive needle-filled jaws. It uses the deep sea's reliance on light against its prey, setting a biological trap. In a deep sea zone entirely cut off from the sun, survival requires that you manufacture your own stars and then figure out how to weaponize them against the void. Eventually, you hit the bottom. The abyssal plain stretches out like a massive, silent desert, covered in millions of years of fine sediment. But the sensors pick up something strange: extreme heat. Right in the middle of freezing water, towering chimneys erupt with thick black smoke. This diagram explains the geology. These are hydrothermal vents. Cracks in the Earth's crust allow seawater to meet raw magma. The intense heat absorbs heavy minerals and forces that superheated, chemical-rich liquid back up into the ocean. Now look closely at the plume. Instead of plants using sunlight, specialized bacteria consume the raw chemicals pouring from the Earth's interior and convert them directly into energy. This process is called chemosynthesis. Before we found these vents, biology held that every ecosystem on Earth required the sun. This discovery proved that life can bypass the surface entirely and power itself using the volatile chemistry of the planet. There is still so much we don't know. The sonar pings, registering an enormous shape, moving in the dark. It glides just out of reach, its massive eye briefly reflecting your light before vanishing completely. Whatever it was, it doesn't care about us. The deep sea survived asteroid impacts, ice ages, and continental shifts. Whole civilizations could rise and fall on the surface, and the creatures down here wouldn't even notice. But they matter deeply to us. These thriving forests of giant tube worms anchored to boiling chemical vents provide astrobiologists with a crucial blueprint for how life operates at the extreme edges of physics. Which brings us back to space. Scientists are now looking closely at the thick ice covering Europa, one of Jupiter's moons. They suspect that beneath that frozen crust lies a massive saltwater ocean, heated by hydrothermal vents identical to the ones we just explored. As the sub slowly ascends back to the surface, the light returns, but the perspective has shifted. Space remains our grandest ambition, but the deep sea is the deepest mystery we actually possess. The next time you look up at the stars, wondering if alien life is out there, remember that it is already swimming beneath you in the dark.